So we're back here and we have 3 questions. I'm just going to read out the questions and then we will work through the answers here. We said the first one, this is using sequence alone, we need to answer these questions. Okay? Mary Williams needs to change a Fahrenheit temperature to Celsius. Use the Fahrenheit temperature of 80 degrees to test your solution. All right, well, we could use any value to test the solution. We just want to make sure that the algorithm is correct. The next one that we'll look at is Bob would like to know what percentage of his income his rent is. Write a solution that will calculate and print this percentage. And the last question asks us to develop a solution that would return the fewest coins in change from a purchase of under $1. So we have pennies, nickels, dimes, quarters, and half dollars. Okay, and this question was a bit of a challenge question, but there is a straight through solution for it. So we're going to take the first question and, answering these 3 questions should take us to the end of class. So we have the first question with Mary Williams and converting Fahrenheit to Celsius. And we're going to take a look at what Emmanuel had in terms of an answer. So I'm going to paste his solution here. I know it is taking up a lot of space, but let me see if I could resize it. Resizing always gives trouble on this for me because it pastes as text. So give me 1 second. Let me just copy it into somewhere else that will paste it over as an image. All right, so it doesn't seem to be coming in. I'll just work with it as it is in the text box here. All right, so it'll just be large. Right. So we want to, he said here, we will declare the variables. All right, we have to declare the variables. And so his variables are that he has real temperature, Celsius, and inter as a name of a variable. Clement, you want to tell us what the purpose of inter is?
Well, I realized that it was 2 parts of a calculation. So to avoid any errors or anything, I decided to make like an intermediate variable to like store one value of it to then calculate it afterward with the bigger equation.
Right, and I see what happened here. Normally we'll name those variables like temp, but we use temp for temperature. So we're using inter as a kind of intermediate variable or a temporary variable that helps us with processing. Okay, so we asked for the temperature in Fahrenheit, which is what the question asked for, and we got the temperature in Fahrenheit. And the first thing that we did was that we took the temperature in Fahrenheit and took away 32 from it, which is fine. And then we decided to say Celsius is equal to 5/9 multiplied by that intermediate variable. All right, I would just suggest to you that when we're writing for computer science, we put it like this, okay? And so this fractional representation that we have here, we needed to expand it out because remember, we will be typing it on a keyboard. All right, so I just want to try and weed out any little habit like that. And so what we did is that we say temperature Fahrenheit is Celsius. So All right, so what I would do here is I would put commas. So temperature, this tells us that we want the value from the variable temperature Fahrenheit. So this would be like 80 Fahrenheit is, and you put commas here as well. And that lets us know we have a variable, we have a string literal. We have a variable, we have a string literal. That makes sense? Yeah? All right, good. So that's the first one. Let me see if I could just work this a little better. All right, well, I'll leave it as this. And then we're going to use do the second one. We're going to do the second.
Didn't you say to use 8C as the Fahrenheit temperature?
No, they said we could use it to test the solution. So what that means is afterwards, we can put the value of 80 in there and see if it will actually work. So what we could do now, if you say input temp, so temp has the value of 80, then we said enter is equal to 80 minus 32. So 80 minus 32 is what, 48? Yeah? Right, and then we multiply 48 by 5 over 9. So 5 over 9, right, multiplied by 48. Okay, 5 over 9 multiplied by 48 will give us an output of, our output should look something like this. It should look like 80 degrees Fahrenheit. And again, this, well, some keyboards might give you that. So you're able to do that. Is, sorry, 26.667 degrees Celsius. And this is what our output is going to be when we actually perform or execute the algorithm's instructions. So according to what he has here, it works, right? Just before, I see he has the monthly income one, but if anybody else wants to share, right? Otherwise, I will use Emmanuel's own. Does anybody else want to share theirs?
Yeah, I could share mine.
All right, so we'll wait on that solution to come in. I'll set up for it, right? So the question is, Bob would like to know what percentage of his income his rent is. Write a solution that would calculate and print this percentage. So I'm waiting for the solution to come in for that. And then we have the last one, which says we want to have this solution to find the fewest number of coins. Okay. So I'm waiting on the solution for number 2 to come in. Maybe we could work on this solution for number 3. How would we find this? Let's think it through. If I have change, everything needs to be less than 100, right?
Yeah.
So one of my input variables is going to be the change value. Okay? So if they ask me for the purchase value, they might say input the purchase value, and I'll work out the change value from that. So whatever one of my variables is a purchase. So let's start off with that. We know that we have purchase and change, and then we'll have amount of coins, right? So we have int purchase, we have change, we have 50 coin for a 50 cents coin, not coin 50 for a 50 cent coin. We have coin 0.50 is equal to 0. So we initialize a value of 0 for coin 50. Coin 25 is equal to 0. We initialize a value of 0 for 25 cents coins. Okay, what else we have? Coin 10 is equal to 0. Coin 5 is equal to 0. And coin 1 is equal to 0. So we have the amount of coins, 50 cents coins, 25 cents coins, 10 cent coins, 5 cent coins, 1 cent coins. All of them start off at 0. Yes, Uma, the question is, I believe the question will utilize the modulo operation. Okay, so we're going inside of here. So Uma is thinking along the right track. So the first thing is that we have to say printf, sorry, not printf, print, please enter the purchase amount. Because they said that, right? They said that the value that we are getting is that purchase amount. So we input purchase. And from purchase, we can calculate the change amount. So the change is going to be equal to 100 minus purchase. We're making the assumption here that we're making the assumption here that this value, this purchase value here is always going to be this purchase value here is always going to be less than 100. Okay. And then now we could start to calculate our coins. And so the amount of coins that we can get, 50 cent coins that we can get here, right? We can say .50. Sorry, I thought I was writing. 50 is equal to change mod 50. What is going to, sorry. Yes. No, sorry.
Excuse sir.
My bad. No, sorry. Coin 50, I'm jumping ahead. Coin 50 is equal to the change divided by 50, not mod yet. So if it is that, let's say, for instance, my change was 75 cents. 75 divided by 50 as an integer result will give me how much?
One.
It will give me a value of 1. So I will store the value of 1 inside of coin 50. So I don't even think I need the modulo operator in this instance, but we will see. We will see. All right. So change divided by 50. So what do we want to do? We have to store the remainder of the change so that we could check it with other coins. We know how much 50 cents that we have. We could use back the same change variable. We could say something like change is equal to change minus minus 50. All right, well, let me be consistent, even though it would make a difference for 50, right? Change minus coin 50 multiplied by 50. Multiplied by 50. So what does this tell me? if I had that 75 cents as my original change value, and I say coin 50 is equal to change divided by 50. Coin 50 now has the value of 1. So what I am doing here is I am going to say do what's on the right-hand side first. Because for the assignment operator, we do the evaluation on the right-hand side and we put the answer onto the left-hand side. Okay, so I say here 75 minus 1, which is the value inside a coin 50, multiplied by 50 is going to be equal to 25. You all with me? So now the new value inside of change is 25. So the next thing that I could do is I could start to work out how many 25 cents coins we'll need. Okay, so we say now coin 25 is equal to change divided by 25. How many 25 cent coins we'll have left over when we do this, right? We have 25 divided by 25. So coin 25 is going to be holding the value of 1. And again, we could repeat the same statement. We could say change is equal to change minus 0.25 multiplied by 25. How much ever? And here's the reason why I'm doing this. Okay, here's the reason why I'm doing this. I'm going to erase what I have here, and I'm going to start off assuming that I had 74 cents in as the original value for change. So let's say my purchase was 26 cents, and my change is now 74 cents. This is my change. When I do the operation with coin 50, I'm going to get, in coin 50, I'm going to get 1. So I have 1 for coin 50, which is going to say that the amount of change that I have is 24 cents. Okay? So I then go and say coin 25 is equal to change, and I have an equal sign here, not a minus sign. I apologize. Coin 25 is equal to change divided by 25. 24 divided by 25 is how much as an integer?
0.
0. So coin 25 remains at 0. Then I say change is equal to change minus coin 25 by 25. So if my change was 24 here, minus, what's the value of coin 25? Currently
0.
it's 0. 0 multiplied by 25 is 0. So my change is still at 24 cents here. So that I could go on to the next value. I can go on to the next value, which is going to be my 10-cent pieces. Okay, so I will again say coin 10 is equal to change divided by 10. And what am I going to get as a result for coin 10? My change was 24. So 24 divided by 10 is going to put the value of
2.
Coin 10 will take the value of 2. And that leaves me with how much cents left over? Say change is equal to change minus coin 10 multiplied by 10. So coin 10 had the value of 2, coin 10 had the value of 2, and we want to take that away from change, multiply that by 10 and take that away from change. Now we will be left with 4 cents inside of change. And just like in the case of 25 cents, because we can't make a whole 5-cent piece, we will end up doing, having the same behavior, even though we have the code for it. Coin 5 is equal to change divided by 5. Change is equal to change minus 5 multiplied by 5. But coin 5 is going to take the value of 0. It's going to have the value of 0, right? So for coin 5, we will have 0, which will leave us with 4 cents change. Okay? And then at the end of this, we don't have to count the value of coin 1. We could just simply say coin 1 is equal to change, because we have no coin 1 is equal to change. So because we don't have any other divisions to do, we have just 1 cent left. Okay, we know that for a fact. So that the last thing that we do is that we say we print out there are coin 50. There are coin 50 cent coins. And you copy this going down. Okay, so, and then you change up those values there. Right? There are coin 25 cent coins. There are coin 10 cent coins. There are coin 5 cent coins. And there are coin 1 cent coins. And this would be your algorithm. Okay, so we could, again, let's just check it with a value and see our logic going through it. Okay, let's see a value where, let's see if we'll get the 99 cents was, sorry, not 99 cents, 1 cent was our purchase. So change has the value of 99 cents at this point in time. For coin 50, we will get 1. And what does that carry change to? That will mean that 99 minus 50 is 49 cents. Yes, Clement, you have a question? Clement? I see your hand up.
Yeah, you can hear me now?
Yes.
Sorry, my mic giving me trouble. So,
Okay.
I want to say like we could probably use some for loops to like make this shorter.
Oh, yes, but that's not where we are at.
But yeah.
This is we could, yeah, you can get a nice simple solution if we were using for loops and arrays. But the thing is, and again, remember, we're in problem solving. We're trying to solve this problem within the scope of information that we have right now. And the scope of information is that we can only create a sequential program. And the thing is, CXC has given problems like this in the past and say you cannot use an array, or you need to solve this without looping. Okay? So this is where our thinking skills has to come in. It's not only about, being able to solve it most efficiently, but we have to be able to solve it within the constraints of a particular set of problems. Fair? Yeah? All right. I guess I see your, yes, I see your hand up. All right, so we have 49 cents. And that 49 cents now, we have to see do we have 25 cents inside there? Yes, we do. So for the coin 25, we end up with 1 25-cent piece inside of there. 49 minus 25 is 24 cents would be left over. Then we have to pull out the 10 cents. Okay? We have to pull out the 10 cents. So the 10 cents will come up to 2 10 cents, and we'll be left with 4. Sorry, this one is for coin 25, and this 2 is for coin 10. And then we have 4 cents left, so we end up with 0 inside of coin 5, which will at the end bring us down here with 4 going to coin 1. So when we have 99 cents, this is what we'll print out here. Everybody with me? Good. All right, so we have the solution for this. Let's just take a look at the last one, which was sent in the chat by, all right, copy image. Hold on, I have to, I want to bring it in as an image prop. Good. Okay, so we have Bob would like to know what percentage of his income his rent is. And this was sent in by Brandon. Write a solution that will calculate and print his rent. So we have declared the variables real, rent, total income, and percentage. As our inputs, I think this is correct. We have rent and total income. Okay, I would advise you to put a prompt here. Output, enter, rent, and income. Okay, so we put a prompt, and that prompt is considered part of our input, even though it's an output statement, because it guides our input. Okay, the percentage is rent over the total income multiplied by 100. And then we print out your rent is percent of your income. So that's great. This is a good solution. Let's just test it with some values. Okay, so we have input rent. Our rent could be, let's say our rent is 2,500 and our total income is 11,000. Right? The percentage will be 2,500 over 11,000 multiplied by 100 over 1. We have, cross out, 110. I'll just use my calculator for speed because we are at the end of class, right? All right, so we'll get 22.7 basically, right? We'll get 22.7 as our rent, so we'll print out 22.7% of your income. Any questions? Elon packing up. Yeah.
Yes,
Yes. You have to exit the building. All right. So it was great. I hope that we We had a good time. I'm going to stop the recording and just recap what we did. Well, let me recap first. We essentially had a general solution to the problem. Sorry, a definition of an algorithm being that it provides answer to a problem when a series of steps are followed. We took a look at properties of the algorithm being the general solution to the problem, clearly defined and unambiguous steps. There's a finite number of steps, and there must be flow of control from one step to another. We took a look at our different control structures, sequential structure, decision logic or selection structure, and looping structure or iteration structure. And then we got into learning about input and output and processing as a way of approaching input, processing output as a way of approaching developing our algorithms. So we look at actually what statements we use to input and output. And we take a look at expressing our instructions as statements, mathematical statements. After that, we did an example using the circumference and area of a circle. And then we did some questions, some nice challenging questions. And Elon, yes.
Yes, sir. How'd it go?
No problem, yeah, I realize.
Everybody said,
All right, bye-bye. Right, and we took a look at our solutions for two of them, which were very well implemented. And then we had a bit of a challenge question that required some thinking that had us stepping back to only using sequence, right? Because I know that you are all able to produce algorithms, but we have to produce it within the scope of, within the scope of having to be able to meet the criteria. And we did that in this instance, right? So any questions before we say goodbye? No? Okay, I'm gonna stop the recording now.